Okay. Welcome everybody to the webinar organized by GuarantEE. Um, we have organized a webinar about measurement and verification of energy performance contracting. My name is Irma Thijssen. I work at the Netherlands Enterprise Agency, and I will give a very short introduction of GuarantEE. And after that, I give the floor to Sven Wuits. He is working at Factor 4 in Belgium. And he will tell a lot about measurement and verification and about the International Performance Measurement and Verification Protocol. And after that, there is a possibility to ask questions. You can use the question mark above in the navigation bar. Um, well, we'll start with the introduction of GuarantEE. Um, please, the next slide, please. My assistant will give us the next slide. The GuarantEE project is a project with 14 European partners, and together we try to stimulate energy performance contracting in the private and public sector in Europe. And the GuarantEE project is co-funded by Horizon 2020, and it runs from April 2016. Mag ik even de volgende slides? Until March 2019. The webinar will be broadcasted and it will be recorded as well and will be online on the GuarantEE website. And as I just told you, you can ask questions by using the question mark. And next slide, please. The GuarantEE project is coordinated by the Berlin Energy Agency, the Berlin Energieagentur, and there are 14 partners. Next, please. I don't know if you are familiar already with the website, but the GuarantEE website offers a lot of interesting information about energy performance contracting. And for example, there's a database with a lot of best practices, and all 14 partners implement their best practices in this best practice database. This year we have also developed the EPC pre-check. It's an online tool. It's free available, and it has already been translated into 14 languages. And please feel free to use this tool. And it gives you in only a few minutes time, it gives you an idea if EPC, energy performance contracting, might be interested for a building owner. We have also introduced the EPC Facilitators Network. And here you will find the links to the GuarantEE project and the GuarantEE website with 14 different languages, and also the forum. And the forum is especially for experts, which I suppose you are. Well, that was a very short introduction. Please feel free to look for more information on the websites. And for now, I will give the floor to Mr. Sven Wuits for his presentation on measurement and verification of energy performance contracting. Thank you.
Thank you very much. I will show you my screen. Just 1 second. Okay, here we go. Thank you everybody for joining us. I will talk about half an hour about MNV projects, or MNV, measurement and verification in energy performance contracting projects. I have to shift the slides myself. I don't have any assistance to do that, but should be no problem. First, I want to very briefly introduce Factor 4. We are a small company of about 7 people, and we are all engineers and financial experts. We are based mainly in Antwerp, but we also have a small branch in Amsterdam, and we are specialized in energy comfort maintenance in buildings with a performance guarantee. Our website shows what we can all do. I don't have to go into too much detail on that. If you want to contact me later on, you can find my contact details on the website. As for the webinar today, I will discuss a few points. Measurement and verification is a very broad subject. We can talk about this for days if you want. I will try to give a very limited introduction so that everybody's more or less up to speed about what it means, measurement and verification. So first, I want to very briefly discuss performance contracting. I will not go into too much detail, but because I assume everybody knows more or less what performance contracting is, but it's important that everybody understands what we mean by performance contracting. Then I will discuss about how are we going to measure energy savings or savings in general. So we have to quantify something that's not there. It's not very easy. We cannot measure energy savings. We have to decide on who does what and when in a measurement and verification plan and in an energy performance contract. There are a number of protocols and standards that have been established to help people do measurement and verification. At the end, I will briefly discuss, or the entire presentation will be basically focused on energy saving, but there are also other performance indicators that can be measured and verified. We'll discuss building value. I will come back on that later on. And comfort is the indoor comfort in the buildings. And then I will try to formulate a conclusion and some kind of action plan if you are planning to do an energy performance contract, and what should you do, or what should you start with right now. But that's for the end of the discussion. If you have any questions, you can enter them in the webinar software, and once they will pop up, I think Irma will interrupt me if there are any urgent questions. Otherwise, we treat the questions at the end of the seminar. So first, I want to illustrate why it is important that we shift to energy performance contracting, or to performance contracting in general. I have an example of a project that we have done at Factor 4, and there was it was an office building where there was a very old heater, and it was replaced by a company with a very efficient and energy efficient heater. It was a very expensive project, but in the end, we were after the installation was done, we were included in the project, and we measured only an energy saving of 10%, and that was very strange, because everybody says, oh, if you move to an energy efficient heater, you can save 20 and up to 30% of energy, but this was clearly not the case in this project. And what we did is we added a regulation system which was not implemented, and it was not implemented because it was not asked. The client himself, he was not aware of the fact that this is so important. He just asked the installer, please give me a new heater, and the new heater was placed and the installer was gone. What we implemented after the installation of the heater is an energy performance contract with Factor 4, where we were responsible for increasing this energy saving. So we wanted to have as much energy saving as possible. And in the end, just by adding the heater regulation, we could obtain an energy saving of 37% with respect to the original situation. So this shows that you have to ask the right question to your supplier. Just don't ask him to replace the heater, but ask him to provide you with 37% of energy saving. And this is what we want to achieve with performance contracting. This is also something that the European Commission is very interested in and wants to promote very much. According to the Energy Efficiency Directive, there is a definition of energy performance contracting. I'm not going to read it. Everybody can read for themselves. But what is important is this part, and it says that the supplier has to be paid for in relation to a contractually agreed level of energy efficiency improvement. And very important in this definition is that you have to really improve the energy efficiency and that your remuneration is in line or in relation with that. That makes it very important to know what is exactly the energy efficiency improvement, and that's where measurement and verification comes into the picture. So if we depict a performance contract project, then we have an ESCO, is the energy service company, that's the supplier of the service, and the client is often the building owner, and the ESCO will deliver a number of performances and certain energy saving in kilowatt hour or in percentage, a certain building value. I will come back on that later on, and a certain comfort level or comfort satisfaction level in the buildings. And in return, the client will pay the ESCO partially a fixed price and a bonus-malus system, where if one of the performances is not reached, there will be a malus. If he performs better than promised, he will get a bonus. That means that the ESCO is also motivated to do as good as possible. But if we connect the energy savings, for example, with pricing and payments, then measurement and verification is really at the heart of an EPC project. So measurement and verification, what do we mean? Measurement of energy savings and verification of the performance. So we can measure, or we will try to measure energy savings, and we will verify the performance. That's the origin of measurement and verification. So it's not just measuring the energy consumption, it's really verifying the performance. Those are two completely different things. So if we want to quantify energy savings, I have an example here. Let's say that this is the office building where we had the heater replacement. So we have the monthly energy use of this building. In the summer, it's a lot less energy use, of course, and in the winter it's more. And you can see that it follows more or less the seasons. And here in March of 2017, the new heater was placed, and we can see that, or at least I think we can see that there is a certain decrease in the energy consumption. I'm not so sure here, but these are basically the raw data. So we can measure the energy consumption, that's no problem. But now we have to measure the savings. We cannot directly measure the savings. We are going to try to measure the avoided energy use. So what we need to do is we need to extrapolate somehow the orange bar. So what would have been used by the facility if we did not implement a new heater. And so this blue line, this is what we are looking for. This is essentially what we need to define if we want to know the savings. So if we try to extrapolate, let's say, the energy use, and we have this yellow line, which more or less simulates or indicates what the energy use, the expected energy use would be. And for example, we can have the baseline. The baseline is the energy use before the implementation of the heater, of the new heater. And we can, for example, just transform or extend this period, and we we will basically verify the energy use of this month with exactly the 4th month of the next year, and so on. So we can calculate the savings. So the blue parts are the savings, and we can see that in the first 2, 3, 4 months we have nice savings. Here in September we have a lot of savings, but here October, November, December we are consuming more than we would expect, and then we compare to the. So there is already a discrepancy, or there is a question mark, or we can put a question mark with this extended baseline. So actually, we should correct for the climate, because maybe the year 2007 was much warmer than 2016, and this will have an impact on the avoided energy use. So what we can do then is make an adjustment of the baseline. So we don't use the yellow line, but we use the blue line, which is corrected for the degree days. So if, for example, in here in what is this, March? Yes, March or April, sorry. In April, we see that the yellow line, which is basically the energy use of last year, the energy use of the expected energy use based on last year is lower than the energy use based on 2017, and this is because there are more degree days in April of 2017. It was colder in that month, so we expect a larger or a bigger energy use. So our saving is actually bigger in this month. Here in September, we see the opposite. The original September 2016 was much colder, so there was a lot more heating demand. September 2017 was much warmer. So this is what the adjustment for the climate is what we call a routine adjustment. This is an adjustment that we will have to do year after year during the entire project. In fact, we have to adjust for the climate. So that's what we call routine adjustments. I will come back to that later, because still here in this phase we see well, we have a nice energy saving here in the first month, but in the last 3 months of 2017 there's almost no saving left. And after a discussion with the building owner, we understood that there are more users since September, so they had an extra floor was used, which was before it was empty, and now there was an extra floor used. So we have to also compensate for that. So in fact, we have to calculate what would have been the energy use if we didn't replace the heater in this building with the additional floor. And that would be the orange line here. And we call this a non-routine adjustment, and we can calculate the savings with respect to this adjusted baseline. So these are 2 very important adjustments that we always have to do. These are 2 examples to show that this is not just a matter of measuring the energy consumed. We always have to do some adjustments to the measured energy to really know what the savings are in this reporting year. So what can we clearly say? The measurement of energy use is really easy. There are a lot of technical solutions for that. I will not go into this in detail, but this is the easy part. Actually, the measurement of savings is the difficult part. And what we need to do is to calculate the savings as the baseline period energy. So we have a drawing here. This is the dotted line is the energy, or the energy use that we actually measure. And so the baseline is the period, or a part of the period, before installation of the energy saving system. So the baseline period energy minus the reporting period energy, which is the measured energy after the installation of the system, plus or minus the adjustments. And then there are 2 types of adjustments, the routine adjustments and the non-routine adjustments. I will come back on that later on. So this formula looks very easy and simple, but it's really important to know what kind of adjustment that need to be done, what kind of baseline period will be selected, what will be the reporting period, and so on. So these things have to be fixed before we start the energy performance contract, because once we are in the contract, we cannot start discussing this because a lot of things depend on this calculation and on these adjustments, and not in the least the money that the ESCO will get for his services. So it is very important that an MNV plan, a measurement and verification plan, is included in an EPC contract. This has to be done before the signing of the contract, because if you need to change it afterwards, there is always the discussion on the money, basically. So every project needs a different MNV plan. We cannot make a standard MNV plan, which is okay for all kinds of projects and all the kinds of energy saving systems. So we need a dedicated project plan for each project. What do we need to put in all these MNV plans? We have to define what is the boundary of measurement. What are we going to measure is the first question. Are we going to measure the overall energy use of the entire facility, or can we isolate one of the systems and measure only the energy use of this system? We need to define the routine adjustments. We really have to identify what are the adjustments that we are going to do every month after month or year after year. And then we have to include all the variables for non-routine adjustments. Many of the non-routine adjustments are impossible or very difficult to predict in front of or at the beginning of the project, but still we should collect a lot of data and a lot of parameters of which we think that they may have an impact on the energy use. So this will also have to be included in the MNV plan. And then at the last point, who will measure what, when, and how? This is also a matter of dividing the responsibilities on the measurements. Who will do the measurements? Will this be the ESCO or the client? And who will perform the calculations? Will this be the ESCO or the client? This also has to be defined. All the options are open. You can choose whatever you want, as long as you agree between the client and the ESCO, of course. So let's discuss a little bit on the boundary of the measurements, and then on the routine and the non-routine adjustments. So the boundary of the measurements, I've made a schematic of a building with an electricity meter, which is the utility meter here. And you have some office equipment connected. There is a HVAC AC system connected, and there is a lot of lighting connected. So actually the retrofit project here is to replace the lighting. So the first question is, where are we going to measure, or what are we going to measure? Are we going to measure, to put the boundary here, and we will measure, just take the readings from the electricity meter, and then we replace the heating, the lighting, and then we measure again the utility meter, and we see the difference. But as you can imagine, there are a lot of other parameters that have an effect on this general meter, so it's possibly not a very good idea to use this boundary. The selection of the boundaries is always connected to the price of MNV. This is also a very important aspect. It doesn't make any sense to install a very, very detailed measurement and verification strategy, which is very expensive and which consumes all the savings, for example. So we could imagine to measure only the energy consumption of the lighting circuit, but then we would have to add an additional meter, which in this case is very simple. It's only 1 meter, but in some cases a little bit, depending on how the electricity scheme is organized, this may be very complicated. Also, with respect to the boundaries, we have to think about interactive effects. This is something that also has to be dealt with in MNV plans. There is, once again here, there is no general rule saying that if you replace the lighting from just normal light bulbs to LED lighting, then your air conditioning will work 20% less. There is absolutely no general rule. So this has to be assessed for in every project separately, because if we replace all the lighting with LED lamps or LED lighting, then the airco will also save some energy because it will there will be a lot less cooling capacity needed in some cases. So this is also something that has to be assessed in the MNV plan. How are you going to deal with these interactive effects? If they are considered negligible, it's okay. But if everybody agrees that they are negligible, then it's okay. If there is to be made an estimation, then we need to make an estimation. This is an MNV plan is just meant to make clear agreements and between the client and the ESCO before we start the project. That's basically the main point of an MNV plan. So on the non-routine adjustments, so first the routine adjustments, I put a few examples here. The weather, we can consider the degree days, which is a measure of the heating demand of a building. But we can also have the sunlight, wind, relative humidity. Those are all things that are nowadays monitored very closely. So you can ask, you can get all the data from weather stations and so on. And you can try to make or find the correlation between the energy use of your building and also all those parameters, and use this model to predict what would have been the energy use if we didn't change anything to the facility. Also things like production volume. This is, for example, in a production facility. If we are the energy use is depending on the production volume, then this is also a routine adjustment that can be done. The number of visitors, for example, in a swimming pool, this could also be an independent variable. In the MNV plan, we have to agree on the calculation. How are we going to adjust for these parameters? This is the formula really has to be put into the MNV plan. We cannot start discussing on this later on when the project has started or when the measures have been implemented. This calculation can be very simple, but it can also be complicated with statistical models. It depends a little bit on the energy savings that are expected, the kind of measures that are being taken, and so on. Also, there are some issues on precision on significant digits. This is not a very sexy subject, but it's important, or it can be important in MNV plans. These things are always to be considered. In some cases, it can be agreed between the parties that it doesn't matter how many significant digits there are, but then this has to be still clearly stated. As for non-routine adjustments, I have some examples like the facility size, if they add another floor or they use more of the unused, or they use more space that was unused before, for example. Also other retrofits, for example, in our project where we replaced the heater, for example, after 3 years, they will start isolating the building envelope and put new windows inside. This will have a very big effect on the energy consumption. So this is something that we have to monitor. We have to check what is the building envelope like at this moment, and we have to check and we have to keep this in mind, that we need to check this every year. And for example, if they start isolating the roof, we need to know this and we need to make the correct adjustment for that. Also, indoor environment requirements. If before the people in the building were all, I don't know if I can say this in the current times, but if they are all men and after 2 years the people in the building are all women, then the indoor environment requirements may change. Maybe people will increase the indoor temperature, for example. If these are things that happen, we need to also correct for that. This is something that needs to be monitored. So we need to identify and monitor all those factors. And if something changed, then both parties need to know that there may be an adjustment needed to the baseline. Okay. Some other thoughts on those adjustments is sometimes the test or the measurement is done by using adjacent periods. So some kind of on-off test. If there is, for example, in some cases on the regulation of a heating system or a cooling system, we can switch on and off this regulation system, and we can use very short periods, very short cycles, and we can switch it on and off, and we can compare the energy before and after, or the energy used before and after the switching on or off. Then we are sure that all the other parameters are still the same. The outside temperature, if we use a cycle of about half an hour, the outside temperature will not change very much in half an hour, for example. If this can be done, it depends, of course, a lot on the energy efficiency measure that has been taken. Then this could be a very useful and interesting way to measure energy savings. Also, sometimes I spoke about, before I spoke about avoided energy consumption. This avoided energy consumption is always based on the reporting period conditions. So we will adjust the baseline conditions to the reporting conditions. That's what I showed before. We adjusted the baseline to the weather data of the reporting period, which is the period after the implementation of the new heater. And this gives us the most realistic idea of the savings or of the avoided energy consumption. The savings are, in this case, is the difference between what we would have used and what we actually used in our facility. But sometimes normalized savings are used. Those are then based on average conditions. For example, here I have the degree days for the last 5 or 6 years, I think. You can see that there is quite some difference between them, but here the red dotted line is the average or the normalized data. I think it's the average of the last 20 years. And this gives an idea of the average saving. For example, if we have an EPC contract of 10 years, then it is more used or more likely or more appropriate to use the average or normalized savings. So we will base all the adjustments on the conditions in an average situation. Also, these average conditions have to be defined in the MNV plan before starting the EPC project. Okay, what should we measure and when and how? So I have, there are a lot of things to be said about this. Measuring energy data can be very simple as going down to the utility meter and writing down the energy use until then every month, or it can be a very complicated management and energy monitoring system, which is completely automatic. But what we need to consider mainly is the cost. This system is a lot cheaper than this system. At least it depends a little bit on the amount of measures that need to be done. But we need to consider the amount of expected savings. So also in the MNV plan, we need to define at least more or less what is the order of magnitude of the savings that we expect, because this will decide how much money we can spend on MNV. If we expect an energy saving of 5%, we cannot spend 1 to 2% of the baseline as MNV budget, because then a very big part of the energy savings is consumed by the MNV, and this is not realistic, or it's not desirable. So also the uncertainty of metering is also something. We can install a lot of meters, or we can have only a few meters. We just need to decide for each project separately what is the uncertainty of the metering that we can absorb and that we can agree upon between the two parties. So the MNV cost must be reasonable relative to the savings. We cannot consume a very big part of the energy savings. Also, the cost of MNV should reflect the acceptable level of uncertainty. So both parties have to decide or to agree on the uncertainty that they want to expect. Also, the risks that have to be taken by both parties, and the cost of the MNV, which is basically dictated by how are we going to measure and how much, and how much time or how much data will we collect. This should be discussed based on the agreement between the two parties. So some more considerations on accuracy and precision. You can imagine that depending on the the selected meter, there can be a lot of difference between two measurement systems. Also, some cases, some statistics will come up. Not everybody is very eager to start doing this, but in some cases it is necessary. So it's something that needs to be discussed while setting up the MNV plan. And setting up an MNV plan is the ideal moment to discuss these things. So in order to avoid to have discussions later on. Okay, so an MNV plan in an energy saving project, there has to be a preparation phase. So at a certain moment, we will install the retrofit, or we will install the energy saving system, and then there will be a phase of the project duration, basically. So we need to have the guarantee period is here. So before the project, we have to start monitoring energy and baseline variables. So we need to identify which are the important parameters to be taken care of or to be monitored. Also, energy consumption needs to be monitored. If there is something that you can do right now, you can start. Then this is what you should start doing now. It's monitoring the energy and the baseline variables. The more data you have beforehand, the better. And then the MNV plan has to be established before the installation of the retrofit. The MNV plan has to define what will we measure, how will we verify it. It has to be a transparent agreement on the calculations, on the adjustments, and so on. And then after the installation of the retrofit, we execute the plan and we make a report every year or every month or every 5 years. It depends on what is agreed in the MNV plan. Okay, so how should we start working on this MNV plan? There are some protocols and standards available to help you set up an MNV plan. So there is the IPMVP that was mentioned before, is the International Performance Measurement and Verification Protocol. So it's a document of, I think, 160 pages, and it provides a verification framework for energy conservation measures, not only energy, but also water conservation, for example. And yeah, the most important thing in this document is that there is an MNV terminology. It's very interesting to have a protocol that defines terms like the baseline period, the reporting period. It's if everybody uses the same words, then the communication is a lot easier, and there will be a lot less difficulties. There are also some standards. Yes?
Please, 1 moment. I have a small reminder for the attendees. If you have any questions, please use the question mark, and we can see the question, and we will ask them. We will ask Sven to give an answer. So please use the question mark if you have any questions. Okay, Sven, up to you
All right.
again.
So the protocols and the standards. So IPMVP, there's also an ISO, a series of ISO standards, the 50001. There's also 50004, 5, 6, and 15. Those are all standards, and some of them are guidances. Actually, the contents of both documents is more or less the same. It's very similar. The IPMVP goes much more into detail. It's really dedicated to measurement and verification. But the graphs that you see in the IPMVP, they come back in the ISO standards. You see also the baseline and the reporting period and so on. So the ISO, I just made a list of some of the documents that are implemented here. I'm not going to read them, but the ISO 50001 is concerning energy management. If you want to be compliant to this, you have to do a number of things. The document often says you shall do this and you shall do that if you want to comply. The other standards are more guidance standards, and they just give you a guideline on how to measure or what energy performance indicators you can use, things like that. Many of the terminology used here in the ISO are the same as in the IPMVP. So I will discuss a little bit more in detail on IPMVP. This protocol was developed by EVO. It's the Efficiency Evaluation Organization. This is a non-profit organization of experts that are involved in EPC projects, and they noticed that it's not always easy, or that there were a lot of discussions on measurement and verification. So they wanted to put together an independent protocol with some principles and some frameworks. Some of you may have already heard of the 4 options in IPMVP. So they divide the kind of MNV measures in 4 different options, option A, B, C, and D. And depending on what you will measure and what you will estimate and the kind of adjustments that you will do, you will use one of the 4 options. There is an education or a training by EVO, and if you follow it, then you can call yourself a certified MNV professional or CMVP. Those people are familiar with the IPMVP, with the methods and and especially the terminology, and so it is easy for example, 2 CMVPs to discuss among each other MNV, because they both use the same terminology. They know the framework. If I tell to another CMVP I used option B, then he knows immediately what it is about. So going back to my initial graph, what we always try to promote in EPC projects is that both the parties, the ESCO and the client, they both have someone in their team or an external party that is a CMVP, so Certified Measurement and Verification Professional, that will discuss, not apart from the contract, but in the frame of the contract. And this will create a lot of a lot of confidence between the 2 parties, because if they know that the other party also has someone who is familiar with the terminology, who knows that adjustments need to be done and how they need to be done, then this is very reassuring for both parties, and this is especially good for the client, because if the ESCO does not expect too much risk, then his price will also be better. So this is my personal opinion, that each of of course, the budget and the savings and the size of the project has to be able to cover this, but this is absolutely a very interesting situation. So 2 CMVPs in every EPC project. This is my personal goal for 2018. So I've been discussing energy savings up to now. I will very briefly discuss value and comfort in this kind of EPC project, because we always discuss energy performance contracting, energy. We discuss energy measurement and verification, but we can also have other performance indicators. And also those performance indicators need to be measured and verified. So the value, with value, we mean actually the residual building value. What we try to do is we put a performance indicator on the building value of our building stock, the buildings that we hand over to the ESCO for the energy saving project. So if we ask them, for example, a minimum building value at the end of the project after 10 or 15 years, then we will have also at the end, and we are sure that we will receive a sufficiently valuable building or installation at the end of the project. And the system that we use for this is the condition score, which is the Dutch standard. The number is over there, and this standard is it is actually a standardized approach to assess the condition of each of the elements. So the whole building is split up in a lot of elements. This can be very very coarse or very fine. It depends a little bit on the goal of the EPC project. But for example, here we have the station here, or the pumps here. They have a condition 3. So the condition score is a number from 1 to 6. 1 is perfect and 6 is ready to be scrapped. And with this condition score, after every element has received this condition score, we can correlate this with the residual value. So a new element has a residual value of 100% of the new value, and then the lower or the worse the condition score, the less residual value is attributed to this element. And if we make a nice table of a complete building, this is a part of a building in Brussels, that's why it is in French, but you have all the elements and they all have a condition score. So 1 is good, 6 is bad, and we have a new value for this element. And then we have this residual value. And if we sum up all the residual values, we have the total building value or the total residual building value. And this needs to be, for example, at least the same or better than at the beginning of the project. And this is something that we impose or we ask from the ESCO. And after that, the ESCO is more or less free to choose whether he will replace an element or he will refurbish it or he will add more elements to the table or to the building in order to improve this residual value. So this is also something that can be measured and verified throughout the project. Then as for comfort, there is also for example, in IPMVP, there is a volume related to indoor air quality and indoor environment. But this is mainly focused on measurements. So we will measure the indoor quality and the draft and the cold radiation and so on. But there are also other solutions or other options. And we can, for example, also as a performance indicator, use the comfort satisfaction. And this would be based on a survey of office workers. So in an office building, we will ask all the office workers what they think about their comfort. How satisfied are you about the comfort in many different, on many different aspects. And we have established a database on which we can apply a statistical model. And this will provide us with objective results. So things or the outliers will be removed. There will be a number of correlations between different aspects that will be included in this statistical model. So in the end, this will be an objective result, whether we ask all the ladies in the buildings or we ask all the gentlemen in the building, the overall comfort satisfaction score should be the same. So if you ask, if we perform this comfort meter, the building users fill out a questionnaire of about 60 questions, I think, on different issues, and in the end we receive a comfort meter report where we can see the worst case or the worst practice and the best practice and the score of this building in a number of aspects. So the temperature, air quality, sound quality, also office and building, the light, the cleanliness, things like that. So you can see that this building scores very, very good on lighting, but not so very good on temperature overall. So this comfort meter can also be used as a performance indicator and can also be measured and verified. Just as long as we agree on this in the MNV plan, we can include, for example, also this comfort meter. So the last slide on conclusion. The first conclusion is quantifying project results is not easy. I tried to illustrate this with the first rather simple example. We cannot just measure or take the invoices from the utility, or we cannot just take the utility meter. We need to do some adjustments, and this is not easy. In some projects, it is less difficult than in others, but there is always some calculation to be done and to be agreed upon, and that's mainly what we want to do in an MNV plan. So putting a value on these results, on these calculation, makes it even more tricky. That's because in the end, the payment of the ESCO will depend on the calculations to be done. So this is tricky. This is something that we need to give enough of attention to. So there are some protocols and standards that provide us instructions and options and some framework to set up an MNV plan. Mainly, these protocols and standards can be used to set up the MNV plan, and in order not to forget anything that needs to be in an MNV plan. So the cost and the accuracy of our MNV is actually dictated by the project itself. If it's a project with a lot of saving potential, then there is a lot more budget available to do MNV. It depends a little bit also on this. The IPMVP, for example, has some nice instructions and guidelines on how should you decide on cost and accuracy of your MNV strategy. So every project needs an MNV plan. We cannot make one standard MNV plan for all the projects. That's not possible. And even for the same kind of energy conservation systems, we need to adjust the MNV plan for the specific project or building that we will take on. So if you want to start now, you should start as soon as possible by monitoring your energy and building parameters. If you think of implementing an EPC contract someday, then you should start collecting data right now. The more data, the better. If you don't know where to start or what you should measure, you can talk to, for example, one of the CMVPs that are acknowledged by EVO, for example, or people who have some experience with this can certainly help you. I don't know if there are any questions. This was the last point of the last slide. So if there are any questions, I can try to answer. People can always send me questions later on if you want, or send them to Irma. That's also fine. Thank you very much. I saw that there was one question on the presentation. Yes, but it was answered. So we can provide the presentation. Also, the video will also be put online.
I don't think there are many questions at this moment. The webinar will be available on the website of GuarantEE. We will send you the link, and we will also send you the presentation by email, because there was a question if we could do so. And of course, you all have Sven's email address, so if you have any technical questions, you can ask him by email. Thank you all very much for participating. Thank you, Sven, for the presentation. And maybe we'll meet again. Thank you all, and goodbye.
Goodbye.
Bye.